program. Hi, I'm Production Dave, and this is a short demo of my BE-SAP1 program loader. So to start with, the CPU is displaying the Fibonacci sequence, and I speed the clock up a little bit. And so here in the CPU, it's exactly the same as BE-SAP's one that he showed in his tutorials, and I've essentially hijacked the program mode by wiring up an Arduino Nano into the memory, data, and write push buttons. I've also added a 4-channel dip switch, which allows me to select another program and write it to the RAM. So here you see me loading another program in, so I had to stop the clock and switch to program mode and press reset, and then I select the program that I want on the small dip and I hit the push button to load the program, and it's done. So I enable run mode, disable program mode, and reset the computer, and here we're running the multiplication 7 times 6 program. So I can select a different program by changing the dips, and in this one I choose the up to 255 down to 0 program, and then go through the same process again. Switch to program mode, stop the clock, reset, hold down the load program button for 1 second, and it's done. Way faster than using the dips. Back to run mode, out of program mode, start the clock, and here you can see it counting up towards 255. And I won't bore you with the whole count sequence, but when it gets to 255 it starts counting in reverse back down to 0. So we stop the clock. So the way I've configured the Nano is also to provide a manual override mode, which I'm going to demonstrate now. So the 4th pin on the dips is wired into the Nano. If I enable that, it puts all the data, RAM, and write push buttons to input mode, which basically transfers control back to the dips. So here you see me resetting all the dips, and what I'm doing here is I'm finding the address line 8 in the up-down program, which is where, in my version of it, I store the 1 for the increment, and I'm going to change this to a 3. In order for the Nano to be able to load the program into RAM, all the dips have to be in the open position, so that's why they were all showing Fs and 1s before. So anyway, we set it to 3, and so if I reset the computer now and switch out of program mode and start the clock, it should count up in 3s. And there you go. So I guess this tool makes it easy for us to have some basic pre-built programs defined, and also we can manually override and set the dips. Now here I am reverting all the dips back to their open positions. Remember, on the BE-SAP1 we invert the outputs of these, so it looks like they're on but they're off. So this allows the Nano to drive those pins. If we don't do this, then when the Nano tries to drive the pins, the dip switches override them. It's very fiddly. I had to get these smaller dips because the other ones kept popping off the boards. But yeah, they're a pain to set. And so now I'm going to load in disable the manual override and load in the Fibonacci sequence program, which is the first 2 dip switches in the on position. And I guess the way I've wired this up, I can use 2 dips and 4 programs altogether. That's loaded, and reset, disable program mode, enable clock, and there you go, Fibonacci sequence. So I hope you enjoyed the short demo. It was fun making it, and thanks for watching.